in. Of course, we don't want medicines that are contaminated with cheap manufacturing processes. So let's have good quality regulation of medicine manufacturing. Of course, you could make more money if we didn't have these regulations, but you'd be making money by putting us at risk. So you'd basically be externalizing your costs, and that we shouldn't have that. So I think we should be careful about listening when people say we shouldn't regulate. We should check whether they mean we shouldn't regulate because it's not in my commercial interest, or whether they mean we shouldn't regulate because I'm worried that the regulations will be bad regulations. And for an organization like it's critical to have good regulation and be involved in that process.
So the regulation that we have had so far has by and large been beneficial, or at least not harmful. I'm thinking of a particular case which caused some questions recently relative to the activities that we are doing, which was the use of AI to determine the emotions of people interacting with a machine, which the way things are going looks like it's going to be severely restricted depending on the application. So that's one particular instance where we were looking at measuring emotions, for example, of someone who is interacting with a robot in order to adapt even how jittery the motion is going to look and things like that. And now it's being restricted to health purposes and things like that. So the question is, relative to what we have done so far, it's a question whether there are areas already that are being slowed down, and maybe rightly so. But I know for a fact that in other regions of the world, they are accelerating while we are slowing. And whether this is positive because what we are doing is protecting, in the end, data privacy, which is something that should be done, or whether we have regulated something too soon or to a generic way. That's in the question. Opening the debate. That's
yeah, and again, it's probably worth bringing out all of those actual documents, because there are different views on this, and we should be sensitive to the fact that there are different views on this. I have one set of views, for other people here who have different ones, but yeah, we should reflect the fact that it's not a closed answer here. We have multiple views.
Amaya was shaking her head and threatening me, so I think that we got at least another view for sure. Okay, so what is not debatable is that they do have a role to play in whichever way we make use of them, and that is an element for the future. Yeah, there were other things that have already been filled in as well. So vision for the role of AI-powered robots in the future. We come again to the point that we talked about, the investment in AI tools that enable robots to do more. And the fact that GenAI does not help us in robotics, at least by itself. And or unless we use it as one more tool in a palette of things, bearing in mind we talked at length about the limitations today, about ways forward with hybrid AI. Now, AI-powered robots will become more and more popular and deployed to address a wide range of heterogeneous applications. And it will be an enabler to a large number of yet unsolved problems. So I think both of these comments tie in together very nicely. So we go back to the clear identification of applications which are not addressable today, and see how these tools can be used to address them. Now, Simiro and Adra, that we're going to do in a second. And and then we have an interesting comment. So in homes, now we're talking about the thing we touched on this morning, B2B or B2C. So today they are a very, very different markets. Is there a scope for these markets to converge? Precisely because B2C robotics might become more complex and be able to automate things. So they will automate complex tasks through sensor fusion and reinforcement learning. And there is the question of how they will perform before they have been able to learn the particular environment where they will be deployed. Well, in industrial settings, we will be able to optimize production lines using AI. So this goes into the question of flexibility and being able to adapt existing production lines quickly to new production rates or to new products. And then in general, freeing humans from doing repetitive or dangerous tasks, as robots do, and progressively. So could accelerate space exploration. It's a good point. We did not touch too much upon a space race. And although Europe does have a role in space exploration and in robotics for space as well, so that's also an important point. And may be envisaged as a human augmentation mechanism at the frontiers between organic versus silicon. Okay. Now, we touched upon this earlier very slightly. If there are additional comments regarding this last comment, which I think is important as well because of the forward-thinking nature of the work that we're trying to produce. The convergence between humans and robots is something that you could say it's a Pandora's box, and we can get very quickly into transhumanistic debates that we do not want to get into. Nevertheless, if we are considering the long view and regarding the research that will be funded in Europe and the different communities that could come together, we have talked about materials, we have talked about energy, we have talked about microelectronics. In terms of materials, we are saying implicitly that part of this will be biomaterials, especially if we want to talk about the environmental impact of what we are doing. However, we have not touched upon other more esoteric things, at least from our point of view today, such as wetware. If one is familiar with the word, I think it's the convergence between biological and electronic systems. And also the work that's being done elsewhere in living biostructures that could actually enable applications in some of the areas that we have been talking about today. And now, have we not been talking about it because we are too deep in the robotics community, the people who are present today? And should we get additional views on that? Or is this something where we are all convinced that anyway it doesn't touch on European values and strengths, and it should not be an avenue where significant effort should be put in terms of convergence? I would like to say a few words about this topic. That's going to put teams back again.
For me, I think personally, I think it's obvious in the domain of metamaterials, inorganic mixture of doing interesting mechanisms that at small scale they can do something. And these are really building blocks of the future, probably actuators or even structures that are active in some ways. So it's certainly going to open up really huge possibilities. But I think it hasn't come into the discussion because here we focus on really deployment of systems within
5 to 8 years.
So I know that in ERC and EIC, again, there are projects funded on those topics, but more, as you said, long-term vision. So I think it's a good idea to make a reference to them such that awareness is present in the roadmap.
But not necessarily for a convergence, even in terms of research within the time frame that we are considering.
Yeah, because it's much longer term, I think.
I think Catherine has got a reaction to that.
Well, first, I'm sorry I missed the beginning, so because I was trying to have lunch, to be honest. But GenAI does not help us in robotics. I disagree. Right, and then in terms of human augmentation, I think we need to be aware that technologies are getting nearer and nearer the human body, and I'm thinking of this brain-computer interface that we didn't discuss at all, I guess. But there is Apple 1 year ago that released a tool, a patent for AirPods that are reading our minds, right? I see a lot of work to enable the person with handicap, thanks to it's not human augmentation, it's human reparation, if I may say so, or at least for human inclusion. And I think we should not completely disregard that, because there are neuro atypical people and physically handicapped people that would probably benefit from human reparation or augmentation mechanism to be better included in society. And this is where I think AI and robots, when we apply to ecosystems, surrounding ecosystems, adding the social and human sciences, for me, is important. And where we go back to the values and ethical framework and regulations of Europe. Anyway, that was just my comment. Let's not disregard too much, because there are very promising, let's put it on a positive side, promising work on brain-computer interfaces, and this should not be completely disregarded. That's all.
You are very right. And there is a second reason I brought it up. And I think, Catherine, you know certainly that my team at CEA was involved in the Clinatech experiment for brain control of exoskeletons for tetraplegic patients, which turned then into a collaboration with the EPFL. So you cannot, I think we can say that in terms of let's call it invasive brain control interfaces, Europe is not lagging behind. And I know follow the news still, and Elon Musk is also having similar trouble with the patients that have been implanted. But there are ongoing efforts, and if you look at non-invasive EEG, that's also making very fast progress. There's huge signal-to-noise ratio problems with that. But I think that when Apple put out the patent, there is work ongoing to do that. And you can view it from the point of view of human-machine interaction, saying, well, what we're doing is making the interfaces between these robots and humans more and more transparent, to the point where we could give robots the ability to sense whether what they are doing is pleasing for the person before the person realizes, and we can just focus it there. We are doing work on that at a national level in France in the organic robotics program, of which I am co-director. And this is using robots as an extension, whether it's a physical extension of the human body in prosthetics, and how to connect them, or as physically disconnected parts of the person, and not only in healthcare. So there's also the question, you could say that this is beyond the scope of what we're doing, but I really wonder if how far beyond it is, actually. How could this be used, for example, to help handicapped workers also in factories and in industry? So the convergence between the two is a subject. I don't know if we can say that it's not a mainstream subject and it's not what we should be focusing on, but it's not something that we can neglect. And then if we get into the convergence more even of the electronics and biological side, it becomes, you could say, even more disruptive, more ethical issues. and more long term. But with whatever we propose, we should also give direction for what should or might come after, rather than propose that we just focus on applications within 5 to 8 years and neglect the upstream R&D effort that should already be taking place now. So I think that has to be an element in it. And we had huge debates within the French robotics community regarding this convergence between electronics and biology, and whether we would focus on it. And so far, we have not focused on it as a result. And I don't know if there are any differing views saying yes, we should put an emphasis on that, and there is a position for Europe to catch there. Thinking all of our minds, this is fraught with ethical issues from the beginning.
Well, at least you have biomimetism. That is a very interesting area that links biology and
yes.
And but you know, when the generative AI, I made the whole of the digital team in SGP laugh about it. But when ChatGPT was released, I say, yeah, soon we're going to talk to birds, to cats, to trees, to grass. And if we are able to understand their language, then we might respect them better. And that makes them laugh. But for me, using generative AI to better understand the language of nature or the living beings is a massive topic that we should not. DNA is a language, just to say. DNA is a language. So whether it's part of the report, I don't know. But at least I think it's a very interesting topic.
It is a beautiful topic. It could be relevant for environmental services robots.
Right. And AI-powered robots, for me, at least, biomimetism is a potential very interesting topic.
This ties into the generative design topic as well. So
right.
You can incorporate biomimetism in
and
how
that
components
is less long term, or and here we do need cultural values and social culture, right, being embedded into whatever we do, definitely. Anyway, so it's not for today, and it's not. We took a very pragmatic approach.
But we have brought it out into the open.
There's a vision for the future, and the vision for the future is not necessarily not talking about that. Right? I think we should talk about it as a vision for the future.
Thank you, Catherine.
Can I just add one last thought on this? I think it's very different interfacing in the brain, trying to detect signals with all its problems, and really the new types of materials that are going to help the new generation of mechatronics, the new actuators and new sensors. In a way, one of them, the latter, is more enabling and less transformative, less disruptive, like you said.
Mm-hmm.
So maybe this distinction is worth
between the two.
Yeah.
Yes.
Yeah.
Not touching upon the successful experiments in reinforcement learning with biological neural networks for automatic vehicle control, because
I think it was accepted earlier that new mechatronics are going to be part of this evolution of technology in robotics. And new generation of mechatronics, I think they will have to take advantage of new materials, smart materials, systems. Yeah.
Okay, well, if people still want to contribute ideas but don't want to say them out loud because we're touching on a very sensitive topic, you can do it in writing and even anonymously. That is fine. Okay, I'm going to go back to the screen, so we should see the Mentimeter screen again. Yep. I think I was missing one of the comments. I'm trying to show it. Oh. Cannot go down. Can answer to challenges such as unitary parts. Okay, it's good that you didn't see what Meisha did to solve the problem. I feel very embarrassed. Okay, so as a unitary part, so this is lot size 1, and what we were touching upon earlier in terms of flexibility, help and avoid dangerous operations, hard work, and assist them in manufacturing and maintenance tasks. Then, European strengths and limitations. We seem to be distracted by playing catch up with the generative AI bubble, and this is a major weakness. That's something that has come up several times in the discussion today, and it's something that that needs to be reflected as well, at least in terms of what generative AI by itself can do to applications today. So we've already talked about different possible ways forward there. Strengths, this is the second time such a comment appears, and that was a man-machine interaction in Europe. And in terms of limitations, lack of integrators and companies producing. So I think here we're talking about robot manufacturers. And then again, if we look at the different application areas that we talked about, the level of consolidation in each field is not the same. It's manufacturing robotics is much more consolidated, for example, than robotics in health, or even more in agriculture. But where a large mature consolidated market exists in terms of industrial robotics, Europe does have its strengths, but China and the United States are moving much faster today. In terms of a lack of integrators, I have a question, and I don't know if this is something for the person who wrote the comment. We talk a lot about the lack of integrators, certainly at national level in France, and the lack of consolidated integrators. Is this something that we believe is endemic to Europe, and other regions of the world have got much larger integrators? For example, because the market that they can serve in the US and China, for example, is much more consolidated. So are we talking about a specific European problem that we are lacking integrators of critical scale, even in the field of manufacturing? Or is it something that is generalized at global scale? Thank you, Catherine.
Well, this is one of my favorite topic, integration, because we very often talk about transfer from research to industry, and we always, or mostly, forget that in the middle, there is an integrator. And the robotic vector is just a vector, and when you go to the industry, it becomes a solution, so at least it becomes a system. And for me, there is two, in France, I can say, I don't know for Europe, German integrators are bigger. They are definitely bigger. They come from, they do, still I believe they do more special machinery, right? But still they are like 250 people minimum, and they have a reasonable size as far as I know. In France, the average integration company is about, let's say, less than 20 people, and they can take one project at a time, and not necessarily a very huge project. And we are definitely lacking big ones. The big ones come from big groups, like Actemium comes from Vinci Group. Equance Digital come from Bouygues. And so basically big groups needed, Altametris, which integrates drones, in fact, fleets of drones, comes from SNCF. And so basically they needed something, they didn't find it on the market. They were not relying on two small integrators for large deployment. And when they needed, so they needed the large deployment or the large production of specific robots. And then so they created that internally, and then they subsidized it and sell their services to other companies. That's the way we consolidate, in fact, big integrators. It comes from subsidizing from big groups. What I think, so that might be a specific French problem, I don't know. In terms of a pan-European problem, for me, there is a lack of service integrators. If I take medical surgical robotics, and especially surgical robotics, we fund the startups up until, the product is, and the first thing they go is to FDA approval, right? And then when they want to deploy in hospitals, even the French and I believe European hospitals, they go through the four main surgical companies who sell the throwable, I don't know, you say the things you can throw away after the surgery. So, and the robots are sold by that. We need to create, I believe, a network of specialized integrator for the emerging service robots, where we are very good. And I think we are very good in agriculture robots. I think we are very good into surgical robots. I believe there are some service emerging service robotics fields that are where Europe can have a very nice competitive edge, but we don't disseminate in Europe because we don't have the specific integrators and dedicated. Like if you want to disseminate and deploy surgical robots in Europe, you have to have integrators that know how to speak to surgeons. I mean, among other problems, but there is, it's an example. There are other problems to medical robotics, but this one is one. And I think integration must be a big paragraph of the report, because it's a pivot service and service type of companies that enable the deployment, that turns robots into solutions. We need to turn robots into solutions, and that's integrators, what they do.
They are the actors that are closest to user needs today, as they might be.
Well, they're in between the robot manufacturer, the component or technological bricks assembler, right? And the user. They are the link, and we underestimate how strong this position of being the link between research, robot and technological bricks manufacturer or assembler and user. Their role is a pivot role, and we need to support them some ways and create some dedicated, specialized service robots integration. And they do the maintenance as well, and the training of the user. It's part of their role. So for me, they are a pivot type of organization that we really need to support.
Support, develop, strengthening. Okay, so this is something to take into account, especially I would say in the last big chapter of the document. If I'm going
But then
down to
people can disagree, huh? You're all welcome to disagree with me.
Yes, and right now I would say, Catherine, we agree completely, the two of us, and I am assuming that this is the case of everybody else present. But, I think the only point for disagreement could have been that in the future, the need for integrators might be reduced. I think relative to the conversation we had this morning, I do not think that anybody thinks that that integrators will disappear. There are tools that they can have to make their work easier, but they will not disappear. And now thinking about how much of the work that integrators do when they set up a robotic cell, it's actually managing the all the exceptions. It's not just programming the robot to do what has to be done, but managing all the different things that can happen in real life. You can imagine how we might develop AI tools that will help them explore that space quicker and reduce the type of integration, but the role will not be eliminated. And the stronger they are, the faster whatever solutions we come up with will be diffused in the European ecosystem. Okay, I think, now let me just check. We had, no, we hadn't finished the perception of strengths and limitations. So Europe benefits from a well-established research and innovation ecosystem, supported by initiatives like Horizon Europe, European Defence Fund, and fosters cross-border collaborations between public and private. One thing that we did not touch upon, although we mentioned it very, very briefly in the morning, was the extension of collaborations beyond the European space, which is something that is done already by these programs. Welcome to attack me on this. I would say it's marginal in terms of the scale of collaborations beyond Europe. And just as a disclaimer, Rich, I still consider the UK as Europe, so I know that collaborations are much closer there. And how critical this extension of the collaborations beyond the European ecosystem could or could not be relative to what we see happening elsewhere. See, I'm going back to Teams to see if there are any reactions. And there are not. Also, bearing in mind that this collaboration that does take place at the research and innovation stage takes a very different shape when we talk about collaboration between actors, different types of actors. We talk about collaboration between companies and research entities. The landscape does change quite a bit. Did you want to say something, Maxime?
If I may say, if the European market remains fragmented, which is one of the big problems of the European market for deployment and being the real one market for robotic companies and robotic solution, then I believe Canada would be a very interesting country to develop a collaboration for, because it doesn't make like a US, etc., but it opens the door to European companies to go to the US market without having them necessarily become American. And the other country I think is very interesting is South Korea and Japan, of course. Japan, because they lack entrepreneurship. They are unparalleled leader in industrial robotics but they lack entrepreneurship, and they were really asking for, at least in France, they were asking France for bilateral collaboration because we are famous for our startup niche. At the time, we were startup nation, right? And the other one being South Korea, because because more of the electronic ecosystem, because it's they are scared of China, even if they service China. They took the collaborative robotic turn fairly well, and they have a strong service robotics. They have strong service robotics programs helped by the government. And I think they would be a good partner for Asia, again, avoiding China directly, but entering with 1 foot and reasonable foot into the Asian market, going through South Korea. And for them, currently South Koreans, they go to Germany mostly when they want to enter Europe. So I think the one way works, like South Korean, when they want to come to Europe, they go to Germany mainly. I'm not sure we have European companies working with South Korean companies to enter the Asian market. And I think it's safer than with China directly. That's the point. Singapore might be another thing, but I'm not sure. So I know better South Korea and Japan.
Yes, Singapore was a particularly interesting choice, and I know that there have been partnerships developed both by UK and French actors. I'm sure this is the case of other countries. Because of the possibility to quickly adapt regulatory sandboxes relative to much bigger countries. And I know that there are still initiatives in place with Singapore saying, well, let us be the test bed for AI-enabled human-robot collaboration, for example, in different areas. And that was a particularly interesting point. I don't know if Maxime, you wanted to you were looking at me earlier, and I know, because I was hoping, since IMEC is the source of one of the most integrated innovation ecosystems across the planet, and your influence extends right to the other side of the globe directly.
In the AI department for IMEC, I think it's very complex to collaborate with your research partners that are outside the EU if we want to receive external funding. And I think that is something which is currently lacking from an EU perspective. It's fairly normal to collaborate through all kinds of mechanisms. But I think from a global point of view, if we at the EU want also to know partners outside of the EU what our capacities are, that it might be interesting to further invest also in funding opportunities that are cross-country or cross-continent. Such as there are some possibilities, for example, for collaborations with the US, but they're all fairly complex at the moment. And it's specifically for external research funding that I'm talking about.
Yes, because on the other hand, I think there's a lot of direct work for industry, but it's for European players.
Yeah, but and the biochemical collaborations, that's a completely different story, of course. But I'm really talking about
research
and innovation with specific funding that is received, for example, by the European Commission, and how external partners from non-European countries can also participate. Because indeed, what you say, we have a very active global network of partners with whom we can collaborate from IMEC side. It's not always easy to find the right framework. Yes. I'm sure it answers your question.
It does to an extent. We look at the technology transfer chain. It's very different today in its shape and possibilities. The upstream collaboration. I wouldn't call it a chain, but network that you can set up, and also goes to show that you can have a global impact while transferring technology to European companies, which is a positive thing. And that the framework for collaboration with external partners to the European Union is still a complex thing, and there are things that can be improved there, but it's usually a quid pro quo thing. So should Europe be more relaxed in allowing external players if the other country is not playing by the same rules? And so it comes down to a case by case, initiative by initiative. Okay, now moving on, because I think we are running out of time. Let's see if I've got the... found it. We've got human resources. Companies are still looking at strengths and the limitations. We have talked about this at length. Collaboration, infrastructure, lack of private funding retained in EU. We talked a lot about that this morning. And the funding side. Oh. Okay, I'm still discovering things. I think that people are still contributing even at this stage. Thank you very much for that. So the scope of the AI-powered robotics strategy with which of these domains? So now we're looking at the key question of linkages beyond the AI and robotics communities. Which would we prioritize? And so we've got three things that stand out. And startup and SME ecosystem, this is in terms of accelerating the deployment. Open science and data sharing, we are touching upon the critical factors of data and the effectiveness of the upstream research in turbulent times just today. And then high performance computing, so we're talking about computing capacity, and we touched already upon the two different ways between hyperscaling and networking of computing clusters. And materials and microelectronics and skill and talent development are also identified. Main technology challenges.
Can you go back? Can you go back one slide?
Slide.
You had the one with the that's the one. If we're going to make the bold claim that we should focus on HPC, can we give some evidence for that? Because I've seen made by a lot of
we
people.
talked about that this morning. Yes, you're right. So how is it? So where is it useful today in reality?
And or rather, where is it not working for us? I think it's fine to say we need different HPC. That could be clear. But just saying, oh, we need HPC isn't going to move the needle at all. And I think it's really important if we're saying critical area, we should explain exactly why it's critical, because otherwise we just get sucked back into the swamp of, we've got more supercomputers, you'll be fine.
Yes, plenty of capacity, but no application for capacity.
Exactly. Thank you. Just a quick point.
Okay, so are we talking then about, because we're talking about the HPC issue. We know already that for today's applications, the need for HPC is limited. So we're talking about training perception algorithms and things like that, which can be done on existing computing clusters before the deployment of a new robotics application. Then if we begin to consider what might become available in the future, we are revisiting, Rich, what we talked about this morning. So where is training new GenAI models needed today versus what could be needed tomorrow? And are we talking about having more edge capacity because we think that there will be models that will be deployed and not on the robots themselves? Or are we talking about increasing the computing capacity of the onboard electronics? And I don't think that it came out very clearly this morning either.
I think what was clear was like the massive data wasn't necessarily the almighty grail for robotics. So I'm surprised that microprocessing was just like a 1 and that HPC was a 3, to be honest, because I've listened to the conversation today and I thought we kind of agreed that that HPC, big data, massive amounts of data wasn't necessarily what would trigger a progress in robotics, or at least not within models for certain things, and we were struggling finding where actually. So I'm surprised at that graph, to be honest, very surprised. But I'm like Richard. Honestly, I think we need to double proof that.
Yes, and just to reassure you, that part of the conversation was captured and faced and written down. So that's.
So I apologize, I missed the conversation on that part, but I would say that the data itself is very important. The data gathering, especially if you're going to go anywhere near APCs, the whole point is you're trying to deal with a large model and large amounts of data, and the act of gathering, cleaning, getting that data isn't represented here. I don't think the open science and data sharing is quite the same as the creating of the data.
No, it's not. You're right. You could read data sharing in terms of scientific data sharing, and we're not talking about data spaces or collaborating to gather data by different actors for a specific need. They're two different issues. Yes.
Yeah.
Of which the one you mentioned would be the greater issue, or at least the more directly relevant to the application of AI in robotics.
Yeah.
It's no more pulse from this. They're getting to the end of the Mentimeter. So main technology challenges, and this is the part that will go into the main chapter. Something that did emerge is that mechatronics cannot be neglected, no matter how much AI can bring to the table, and very often it comes down to mechatronics and mechanics problems. Especially in terms of translating new things that work in the lab thanks to AI into things that will work robustly out in the field. We have the beautiful example of agricultural robots waddling in the mud. There you go. And more. So challenges include robust perception, real-time decision making, energy efficiency, and actually this is a point where we did not touch enough on today. And it's one of the important points in that is expected in the document, and that is that as more and more applications become possible, the number of robots we can imagine, their energy consumption, how that energy will be carried on board, and the environmental impact and cost of these things, it is expected to change. You can say it's a longer term issue. We looked at this in the organic robotics program in France from a B2C perspective, and came to the conclusion that the ubiquitous deployment of more capable robots in a home context would very, very quickly come to levels of energy consumption that are I would say probably not to the same scale as the discussions with hyperscalers consumption to train LLMs, but not far from that. Actually, and we can see it with the amount of energy that is consumed by mobile devices, particularly smartphones, if you get all of them together. So if they become more ubiquitous and we deploy more of them, then energy will become an issue. And there are questions to be answered regarding the convergence between energy considerations and the rest. So human-robot interaction, we touched upon that as a possible differentiator even for European robotics. The scalability, what I imagine is we're talking about the scalability of both AI and robotics deployment, and then security, ethics, and interoperability, which can also touch on standards. Then cost reduction, and the availability of research infrastructures facilitating the entire AI pipeline. And we did touch upon even the infrastructures necessary to run challenges as one of the things that could be worked on further. And we come to the last slide. What will be needed to make sure that technology gets to market? There was also a call this morning for not neglecting the fundamentals of robotics technology. And I think that's something that has to be stated also clearly in the document. Remember, Farzam and Rich touched on that in the conversation. Then collaboration, investment, regulations, talent, and we talked about training as well for operators. User-centric design, this goes back again to human robots designed to work with and to augment the role of humans, and building public trust. Which means that then again, ethics can become a differentiator if we manage to deploy trustworthy robotic applications. Then, testing and validation of solutions. So as someone who launched the TEF, I'm happy to see that there. So, and the financial support to adopt new technologies. And finally, standardization of the exploitation plan in order to concretize the results and create successful startups, companies, etc. So here we're touching again on how the solutions are brought to the market and how they are financed and the business rolled out without having to leave Europe in order to finance the development. Okay, I am very aware that we have very little time left before we finish. And actually, the amount of information that you have proposed in Miro is probably 1 or 2 orders of magnitude, probably 2 orders of magnitude beyond what we have covered together. Based on that, I do not think that it makes sense for us to go together through that in order to get a few additional comments today. And I am going to be very weak and say that I would not like to take the last 10 minutes to try and even prioritize what you have written there, which is already enormously useful. Finally, relative to the discussions that we have had online, and I am sure that you are all aware from a GDPR point of view that we did record our conversation. So the good side of it is that the discussions that we had orally, we'll be able to capture that as well. And I think that not all of the inputs that have been written down correspond to the discussion. So we will be adding that as well. What we are going to do, because this is going to be input that will be taken now by the editorial team and put into the structure of the document. And as part of it. If you all agree, and if you don't hesitate to contact us directly as well. Aside from gracefully acknowledging your contributions, we will keep you in the loop as the document advances. You will be able to propose additional comments if you wish, and both the Mentimeter and Michelle, if I'm mistaken, please correct me, but both the Mentimeter and Miro will remain open, so you can propose additional input if there are things that we missed in the discussion. I am aware that we have touched on a subject that is as vast as the universe itself, and I'm still very happy and grateful for all the comments that we got today, and hope that this will be a document that will be useful to move in the right direction. I don't know if anybody would like to make further comments. Moving back to Teams, because I couldn't see when people raise their hands. And I think that you asked the question at the beginning regarding the slides that we have used as backup. Yes, we'll share them with Oh, yes. We'll share. Oh my gosh, that's effective. Okay. We will share that with you as well, and again we'll keep you posted. And thank you again for being with us all day long. Exactly. And I hope you have a great evening. And with that, I propose that we close the workshop. Thank you.
Thank you.
Thank you all. Okay.
Don't leave yet. I need to stop the recording. Okay, we need to start.